Good morning, dear students. How are you today? I hope you're fine. Today we're going to start chapter 2 of lesson 1, integers and absolute value. So, we're going to have some vocab, negative numbers, integers, coordinate, inequality, absolute value. What you will learn by the end of this lesson, inshallah, compare and order integers, find the absolute value of an expression. How are integers used to model real world situations? Okay, this is important. The summer of 1999 was unusually dry in parts of the United States. In the graph, a value of -8 represents what 8 inches below the normal rainfall, as you see here. Okay, I want to mark this. Okay, here -8 means below the normal rainfall. What does a value of -7 represent? It represents here -7 below also the normal rainfall. Which city was the farthest from its normal rainfall? How could you represent 5 inches above normal rainfall? Let's see together. Okay, compare and order integers with normal rainfall as the starting point of 0. So the normal is starting point of 0. As you see here, we have here this 0. Okay, this is the starting. Yes, this is the starting normal for. Okay, so I have here also, you can express 8 inches below normal as what? As -0. So the 8 inches below, it's represented by -8 or -8. A negative number is a number that is less than 0. The negative number, a number that's less than 0. Okay. A negative number like -8. Okay, positive numbers like what? +6 and 0 are members of the set of integers. Integers can be represented as points on a number line. Let's see together. I have here the number line. I have here numbers to the left of 0 and less than 0. These are negative numbers, right? I can hear you. And I have here also the 0. 0 is neither negative or nor positive. So the 0 is neither negative nor positive. Positive integers here, numbers to the right of the 0 and greater than 0. Okay, so I have here the number line. As you see, this set of integers can be written as -3, -2, -1, 0, 1, 2, and so on, where it means continuous indefinitely. So, write here example 1, write integers from real world situations. I have here write an integer for each situation. 500 feet below sea level. Below sea level, what do you think? -500. So the integer here is -500. Okay, this one, as you see here. A temperature increase of 12 degrees. Increase here means +12. A loss of $240. This integer is -240. Okay, which integer here is neither positive or nor negative? Okay, I can hear you, Ali. It's 0, right? So let's go. Here, to graph integers, locate the points named by the integers on a number line. The number that corresponds to a point is called coordinate of the point. Coordinate of the point, as you see here, we have here the graph of a point with coordinate with -4. So this is -4. Okay, graph of a point with a coordinate of 2. This is a coordinate of 2. Okay, note that the numbers of on a number line increases as you move from left to right. Okay, from left to right. Okay, and I have here, this can help you to determine which two numbers is greater. Okay, let's see together. This okay, I want to show you this sentence again, as he said to be what? As you move from left to right. Okay, from left to right, here the number increases. Okay, so I can use this to compare between greater than or less than. Okay, so the number from left to right, it moves to be greater. Okay, negative 4 words. Negative 4 is less than 2. Okay, I have here 2 is greater than negative 4. Clear this. Okay, I have here again, as you see, my dear students, negative 4 is less than 2. I have here negative 4, and I have here 2. And as we said before, that when you go, wherever you go from left to right, you increase, okay? And I can draw it like this. You increase from left to right. So negative 4 is greater or 2? Of course 2. Of course 2. Okay, when I say here negative 4 is less than, the symbol points to the lesser number. And I have here 2 is greater than negative 4. Okay. Any mathematical sentence containing less than or greater than is called an inequality. Okay, remember the equation. When I say the sentence, it contains equal, so it's equation. Here, inequality. Inequality greater than or equal than. Focus with me here. Okay. Any mathematical, as I said, inequality. And inequality compares numbers or quantities. It's not for comparing numbers, it's also for quantities. Example 2. Focus. Compare two integers here. Use the integers graphed on the number line below. I have here write two inequalities involving negative 3 and 4. Since negative 3, okay, let's mark this together. Okay, negative 3 and 4. Negative 3 and what? And 4. Where's 4? Here it is. So, as I told you, from left to right, the right is greater. So 4 is greater than. So when I compare, since 4 is to the right, as you see here, of negative 3, so 4 is greater than. Excellent. Okay. And easy one. Replace the dot here with, okay, I want to see. Replace the dot here with less than or greater than in negative 5 and negative 1. Negative 5 and negative 1. This one, okay, it's very useful to use the right and left sides for this. Negative 5, negative 1. Negative 5 here, as you see, negative 5 and negative 1, negative 1. What's to the right? Wherever you go to the right, it's greater. Yeah, so negative 1 is greater than negative 5. So negative 1 is, yeah, greater than negative 5. Negative 1 greater than negative 5. Okay, and here it's written negative 5. We start with negative 5, and he says that negative 5 is less than negative 1. To lose, okay, to understand this, my dear students, to lose 5 pounds is okay, okay, just a moment. Okay, I mean to borrow $5 is worse than to borrow just $1. Yes, okay. So here, moving to this point, integers are used to compare numbers in many real-world situations. Order integers. Golf, the final round scores of the top 10 finishers in the 2000s World Championship LPGA tournament were negative 4, negative 14, negative 1, positive 1, positive 2, positive 5, 0, positive 3, negative 10, and negative 2. Order the scores from the least to the greatest. Okay, graph each integer on a number line. I have here the number line, and I will graph each integer. Write the numbers as they appear from left to right. Okay, so here as they appear from left to right, as you see, I have here negative 14, negative 10, negative 4, negative 2, here as it's sent on the number line. Okay, so this is the order from the least to greatest. It's very easy now. Okay, absolute value. On the number line, notice that negative 5 and 5 are on the opposite sides of 0, right? I have here the 0, and I have here, okay, want the marker? I have here the 0, and I have here positive 5, and here negative 5. So, I have here, as you see, they are both on opposite sides of 0, and they are the same distance from 0. The same distance from 0. Here I have 5 units, and on the other side I have here 5 units. Okay, so the distance from 0 is the same. In mathematics, we say that they have the same what? Absolute value. Absolute value is 5. The absolute value of them is 5. Okay? Okay. The symbol of absolute value is 2 vertical bars, or either side of the number. On either sides of the number. I have here the 5. I want the marker. I have here 5, and here this is the symbol of the absolute value. So if I have here -5 as it's written here, the absolute value will give me 5. Erase the, okay, get rid of the negative, right? Okay. And if you have here the absolute value, okay, it's written also, okay, a very good book. This book is very good book. So if I have here positive, I have here the absolute value of positive 5 is also 5. Okay, okay. Word concept or key concept. Words, the absolute value of the number is the distance. Okay, this is important to know. Is the distance the number is from 0 on the number line. The absolute value of a number is always greater than or equal to 0. Okay, the absolute value of a number is always greater than or equals to 0. It can't be -5. If it's less than 0, so it will be negative, right? For example, here, any negatives is not permitted. Okay, so the absolute is always positive. So I have here example 4 expressions with absolute value -8. So -8, evaluate each expression. -8 will be 8. -8 will be 8. As you see here, the graph of -8 is 8 units from 0. Okay, okay, it means that this is the explanation here. So I have here 9 plus -7, the absolute value of 9 plus the absolute value of -7. So when I say this, I mean that the absolute value of 9 is 9. The absolute value of -7 is 7. So 9 plus 7 equals 16. And -4, absolute value of -4, 4. Absolute value of 3, 3. So I have here 4 minus 3. Where's, okay, I want to see it. 4 minus 3 equals 1. Excellent. Okay, let's go. Since variables represent numbers, you can use absolute values notation with algebraic expressions involving variables. I have here evaluate x. Okay, absolute value of x minus 3 if x equal -5. It's easy. Okay, I have some steps to do, but it's easy. So I replace here x with -5. So I will write -5 instead of x. Okay, want to make it more clear. So, okay, going down. Okay, again. Here, this one. I have here 4x. I have here 4x -5. So I have here -5. I'll put it in the absolute value of -5, and I will write here -3 or -3 as it is. Then the absolute value of -5 is what? Is 5. 5 minus 3 equals 2. This is the simplification. Okay, easy, easy, easy. By that we have covered the lesson. Okay, study well from the YouTube presentation and go back to the practice book. Answer lesson 1 on chapter 2. Thank you, my dear students.